Welcome back to Learning with me, Ms. Killen, here at MPB. We are in our 8th unit, exponential functions. So let's go ahead and dive right on into our lesson 4. It says we are looking at exponential functions graph applications. So I can interpret exponential functions on different graphs. We are looking at F, IF4, and SSE3. So let's go ahead and see. Let's use the exponential properties to draw the functions on graphs. So we've got to make sure that we label our equations. We have to ask ourselves, are we increasing or decreasing? And do I have a growth or decay? So here we go. It says y equals 2 to the x plus 2, which is the same as saying y equals 2 to the x times 2 to the 2 squared. So obviously this is going to be 4. So let's go get a different color that looks a little bit better on this purple. So here we go. So let's graph this. Let's see what that looks like. So I am looking at my x and y. Obviously 0 is going to be my 4 because it's being multiplied to that b. So I've got 0 to the 4th. Then I'm going to do 1 and 2. So what is my common ratio? Remember we had y equals ab to the x, where we said this was my y-intercept. Then we said this was my common ratio. So my common ratio is 2. So I'm multiplying by 2 and getting 8, multiplying by 2 and getting 16. So let's graph this. 1 to the 8th, let's just say it's kind of right there. And then 2 to the 16, we'll say it's right there. So I am increasing, is what it would look like. I am increasing. Good job. So the next thing, we need to remember what these are. And I want us to make sure that we are writing on our notes page and understanding what these different symbols on our formula mean. So again, y-intercept and common ratio. Now sometimes my common ratios will be whole numbers, sometimes my common ratios will be fractions. So we need to make sure that we are prepared to see either one of them, and we need to be prepared to use either type of number. Good job. Now let's do some practice. Use the exponential function properties to graph the following. Y equals 3 to the negative x and give 3 points. So what I'm going to do is I'm going to make a table here, my x and my y. Obviously, we have our what? Common ratio, which is a 3. So that means that our a would be an understood what? Yes, it would be an understood 1. So I've got 0, 1, 2, 3. So I'm going to have a 1 here. So how am I going to find that next y value? I'm going to have to multiply by my common ratio. But we've got to look at this. We've got something that we've not seen before. Our exponent is negative. Now, back a few units ago, what did we learn about a common planning part of this negative exponent? What do I do when I have a negative exponent? I have to do what? Exactly right. I have to make it into a fraction. So instead of multiplying by the 3, I have to multiply by its reciprocal. Remember, this negative is going to be reciprocal. So now I am multiplying by that 1/3. Remember, negative exponents always turn the number into its reciprocal. Good job. So let's go ahead and multiply this. 1 times 1/3 is going to give me 1/3. Then I'm going to multiply by that common ratio again and get 1/9. Multiply by that common ratio again and get 1/27. So let's go ahead and graph this. So I've got 0 at 1, 1 at 1/3, so it's going to be about right there, and I'm just eyeballing this. 2 at 1/9, so it's going to be about right there. and 3 at 127. So we're going to say that's about right there. So it's going to look similar. And remember, Miss Killen can't draw a straight line. So is this increasing or is this decreasing? It is decreasing. Now, since it is decreasing, would we say that is a growth or would we say that's a decay? It's going to be a decay. So when I am decreasing, I can also say that is a decay. So therefore, if we flip that, if it is increasing, I could say it's a growth. Good catch. So let's look at the next. All right, so now it's time for you to master. Remember our exponential properties and look for your ending behaviors. Now, I want us to look at this exponential properties just to refresh our memory. So we have the power of a product, we have a power of a power, we have the quotient of a power, we have negative exponents, there is our reciprocals that we were talking about. We have the zero power, which everything equals 1 if it's to the zero power. And then we have our rational exponents. So we want to remember those. So the first one says, if you have the function f of x equals negative 3 times 2 to the x, it has a y-intercept of blank. The graph of the function is blank by a common ratio of blank. It is decreasing as x blank and y is blank. Number 2, which of the following functions would have the same graphic representation of f of x equals 8 times 2 to the x? And then the third one, now graph the function f of x equals 8 times 2 to the x. So you or you and your table partner, go ahead and work these problems. When you get done, come back to me and let's see what we got. All right, so if I am going to look at number 1 and fill this out, I would say that if you have the function f of x equals negative 3 times 2 to the x, it has the y-intercept of what? You're right, negative 3. So then it says the graph of the function is what? Is it increasing or is it decreasing? I'm going to say that it is definitely decreasing. Miss Killen, how'd you find that out? Plugged it into my calculator. Good question. And it's decreasing by the common ratio of what? 2. So I could say as my x's increase, or you can put increase, my y's are decreasing, or you can put decreasing. That's a good job. So now let's look at number 2. Which of these functions would have the same graphic representation of f of x equals x times 2 to the x? Now, you could do this multiple ways. You could plug this into your calculator, or you could hit Desmos. Whichever way you work it, you're going to get the good answers. So here we go. When I put that f of x equals 8 times 2 to the x, and I get that graph, then I put each one of these into Desmos. Which one did we say brings it to the same representation? Well, let's look. So I'm going to put my original right here. So I've got y equals, whoops. So I've got y equals, and I'm going to put 8 times 2 to the x. Now, Ms. Killen, how did you put that x as an exponent on Desmos? Do you see right here where it has a to the b? A to the b is saying I'm going to put some type of exponent that's not a 2. So that's how I did it. So let's put in that first answer choice. So I have y equals, and I have 4 times 2 to the x plus 1, x plus 1. So it is not the same representation, I promise, even though this one is not wanting to let me put it there, and I do not know why. Oh, let's put a parentheses, x plus 1. There we go. Okay, it is the same representation. So if we take off the blue, it shows the red, and then when I put the blue back on, it overlaps it, so that is one of my possible answers. All right, so it makes perfect sense that we put it exactly like it is on our page, because if we went back and we didn't put it in parentheses, and I just had to the x and then put plus 1, obviously it's not the same. So you need to make sure that you are putting these in Desmos exactly the way they are. So that means sometimes we're going to have to put them in parentheses. Good job. So let's try the next one. So I have y equals 4 to the x, and that is going to also be multiplied by 2. So let's take off the blue one. The red one is my original. So then my green is nowhere near the same. So I know that's not a possible choice. So let's look at the next one. I have y equals, and then I have 2 to the, put this in parentheses, x, what, plus 3? Close parentheses. So all I see is the purple. So if I take the purple off and I go back to the red, they overlap. So that one as well is a possible answer. Let's keep on going. So I have y equals, parentheses, 2 to the x, and then I'm going to close parentheses. Whoops. I'm going to arrow over and close my parentheses. Then I am going to again put that to the third. That is nowhere near on top of the red one. So I know that's not a possible answer. So let's put the next one in. All right, so number 6, we're going to put a 2. Nope, we got to put y equals 2, and we're going to put that to the 4x. That's still not laying right on top. So whoa, what happened? Oh, I see. I did not put an equal sign. I put a there we go. So even though they're both red, they're not lying right on top of each other, so I know that's not a possible answer. So let's try the last one. Here we go. We've got y equals, and I've got 2 times 2 to the 2x, close my parentheses. My blue is not laying on top of that original red one, so it is not a possible answer. So that is how we can use our Desmos calculator to figure these out. Sometimes it's just a case of putting the original in and see which one lies on top of it. Good job. All right, so now we've graphed that. We saw on Desmos what that graph looked like. Now, was that an increase or was that a decreasing? It was an increasing, or I could also say it's a growth. Good job. All right, so here's what it looked like. Good job. All right, something that I don't want us to forget, how we read these equations. We need to make sure that we're understanding that y equals a times b to the x and what those two mean. We need to make sure that we're understanding those properties that's going along with this exponential function. We need to make sure that we understand the formula that y equals a times b to the x and what these different equations are looking like on the graph. Are they increasing? Are they decreasing? Is that a growth? Is that a decay? We need to make sure that we're looking at all of that and keeping it in mind. I am so glad that you came to learn here with me at MPB. My name is Ms. Killen. I'm having a great time learning with you, and I hope you have the best day.